Hello everybody, welcome back to a new video. So here we have the solar system, so big and very bright. What are we going to do to the solar system today, so you may ask? Well, dear viewers, do not fret, because we are going to be attempting, at least, to terraform the most random planets in our solar system, planetary bodies. That doesn't extend to just planets. I'm going to try to terraform everything, maybe even the sun. We'll get the maybe in a later video. So the first one on my list I'm going to try to terraform, of course, is Venus. So this one is a unique case because while it is relatively close to Earth's size and mass, it happens to have a very, very thick atmosphere, perhaps as a result of a runaway greenhouse effect that has caused it to become inhabitable, to say the least. Look at it, it's sitting at a nice and toasty 422 degrees Celsius, or from my American viewers out there, 792 degrees Fahrenheit, which is just insanely hot. So, how are we going to get rid of this insane heat, you may ask? Well, dear viewers, we are going to be throwing a large rock at it, as is the solution for most of our problems. We'll just throw something very big at it very fast, and sure enough, before long, or maybe, after a while, according to simulation time, it'll cool down and perhaps have a greater effect than we anticipated. So let's throw it at a whopping 20 kilometers a second. This is enough to guarantee a forceful impact that may or may not change the rotation or the orbit of the planet. So here we have the moon. We're going to launch it at a very rapid speed. First I kind of want to see, whoa, what the fuck? Okay, I didn't need that to happen. What? Okay, I don't understand what just happened. And perhaps I need to slow down the simulation. It's running at a whopping 17 days per second, so maybe this will fix our problem. Yeah, I believe that's what was causing it. Here we go, viewers. Okay, now we are going to attempt to throw the moon at it at a whopping 20 kilometers a second. What will this do, you may ask? That I do not know for sure. Okay, looks like I need to get a little closer. What is with me today? I don't know. Something's up with me. I kind of want to throw it at the same trajectory that the planet is coming from. Oof. Okay. Now that may have had the effect that I wanted it to have. I don't know. So it got very hot all of a sudden, or all of a sudden. Sorry, I don't know. I never know when I'm saying that right. Now it is at a 11,000 degrees, which is just terribly hot. I hope this isn't enough to destroy the planet completely, as it is destroying this moon that we threw at it. Now it's way smaller than it was before. It's losing mass very rapidly. So what we need to do now is wait. So the reason why I chose Venus first is because of its relative proximity to the sun, at least compared to Earth's. It is, let's see, I want to see what the semi-major axis is of Venus, at least this Venus in our own system. Its orbital period is 7 months, and it's about 70% of an AU, which is, not that bad. So maybe after a while, it will actually cool down. So let's run the simulation a little faster. See what its effect is. Okay, now there's just an insane orbit with these moons. I guess I didn't throw them fast enough to escape the sun's gravitational pull, so now we just got this weird moon system going on. And Venus still looks like it's very hot, so let's give it some time to cool off. You can see down in the bottom right hand corner what it looks like. Okay. Wow, that didn't really have any effect. We're trying to get rid of the atmosphere, so what can we do to get rid of the atmosphere? The thick atmosphere. We could always just manually change it, but that's cheating. So, we're going to go back to Venus right quick. We want to get rid of some of its mass, so maybe we'll need to chunk something even larger at it. First, we need to slow down the simulation big time so this works. Okay, now it's slowed down to about 36 minutes per second. Let's try throwing something way bigger at it. Maybe something that'll cause catastrophic damage. Nah, not another Venus. Mars ought to do it. Okay, yeah, Mars is always a good test for these kinds of things. So let's see what effect this has. Okay, wow. We pause it right on impact. So let's slow it down and get a better look at this. I like how they animated the shockwaves in it now. So now you can actually see some of the, I guess, forceful winds that's causing this giant explosion, or caused by the giant explosion. As you may notice, it is consuming the planet rather quickly. And of course, here comes the music to make things even more dramatic. So let's turn off trails. Just get a better look at how it appears. So I hope this isn't enough to destroy Venus, even though it is losing mass at a rapid rate. Let's just speed it up and see what happens. Okay, never mind, it's gaining mass now. Okay. It's very, very hot. I hope Venus doesn't just evaporate before our eyes, because that'll be very sad. Okay, we can see it cooling off, and I swear if it comes back to that same atmosphere... Yep, it sure did. Even though it gained mass, so I don't know what to do. I should have compared the atmospheric composition, so let's look at the surface, see how it appears. Okay. Atmospheric mass, yeah, it is extremely heavy. So let's figure out what we can do to solve this. So, dear viewers, I think we may have figured out the main problem, the main issue here. The tangential speed at the equator is only, whoa, 1 meter a second. Okay, that is insanely slow compared to Earth's. Now, a rotational period, which I probably should have mentioned first, how long it takes for the planet to rotate once, is 243 days. If you change that to months, it kind of seems like the planet's tidally locked. Yeah, the rotations take longer than an actual year on Venus. So, to change this, we got to figure out what rotation the planet's speeding from, and then we have to throw an object at it in such a way and at such a speed that it permanently disrupts the rotational speed of the planet. So to do this, or to accomplish this, we have to throw something at the side of the planet. It has to be going very fast and it's going to have to be very, very big. So maybe a Mercury. This is a Mercury-sized problem. If we do this, I notice the farther we get, or never mind. So we're going to have to throw something very big right at the equator. And we're going to change it. It's already sitting inside the planet as we spawned it, so we're going to have to change it to be very fast. 58 kilometers a second, 581 kilometers a second. Let's see what this does. Oh god, this is probably going to make the game lag. So we're going to have to slow it down. Okay. Let's track the rotational speed changes, if any. Assuming it's spinning at the equator, which it may not. So let's see if this is actually having any effect on the rotational period. Okay, yeah, we've definitely changed things around here. So let's go ahead and remove the mercury that we just threw at it before it gets any hotter. The impact, oh god, okay. So we may have just broken things a little bit here. The planet is quickly losing mass, and we don't want that to happen. So it seems. Oh, geez. Okay, we're gonna have to, like, control this temperature that it's emitting. And now the days are just extremely fast. So, we're gonna have to cool it down manually, I think. Okay. This is gonna be a very painstaking process. I'm afraid the planet's just gonna evaporate, which I don't want to happen. Okay, it's heating up so fast. Is there any way to stop this? Probably because I threw the planet so fast. It's probably what's causing it. The rotational period, oh my god. And the orbital period's changed a lot too. Now it's only 3 months. So this may be another issue for our planet, just because it's probably going to be orbiting much closer to the sun. Let's try to control this temperature for now and see what changes. God, it's like millions of degrees. I don't want it to lose any more mass either. Let's see what happens. Okay, now it's going down. Alright. It looks like it only wants to be at a certain temperature. God, what did we do? I think we just broke it. Oh, wow. Okay. The planet's just been annihilated. Does it even exist anymore? No! No! That's not what I wanted to do! Oh, shit. Alright, there we go. I believe these are the results I wanted. I threw Mercury at the equator, facing clockwise from in which the planet's rotating, which I believe caused it to spin so fast and with such force that... Let's take a look at how long the days are. Okay, Wow, okay, it's almost the mass of Earth now. But it's insanely hot. I'm sitting at about 16,000 degrees Fahrenheit. Holy shit, that's hot. Okay, at least they kept Fahrenheit. I'm okay with that. Rotational period is 10 hours, so I think I actually threw it in the other direction. Oh well. So notice that it is very, very hot. Let's hope that it doesn't lose all its mass. And it looks like it's, yeah. Oh, no, it looks like it might survive after all. Oh, please survive. Nope, it's dying. It's slowly dying. I can tell. It's getting too hot. Let's, yeah, there we go. That's way better. Okay. It's been 100 years since I threw that. So, or since I threw Mercury out the planet. Let's see how it's looking now. We slowed it down to about 5 days a second. Oh, wait. Huh. Interesting. So, the atmosphere isn't as thick anymore. And let's see what direction it's rotating. Now we can tell what direction it's rotating. Okay. Actually not so bad. And now notice the temperature is only 380 degrees, so we managed to bring it halfway down. And it looks like the planet has a rotation of about 45 degrees, which is strange to see. So now that I've managed to accomplish a little bit, I'm going to skip another step, and I'm going to decrease the atmospheric mass. So it's sitting at about 4 times the atmosphere of Earth. Temperature's still too hot. So let's see. I guess there's really no way to fix that except get it further away from the sun. So, oh no, it says it's 1.14 AUs away now. Oh yeah, it really is further than the orbit of Earth, but that means it gets really close during the summer months. So let's see how the temperature changes throughout the year. No, it stays about the same, probably because of the extreme thickness of the atmosphere. Alright. So now that it's sitting right here, what I want to do next, at the furthest point away from the sun in its orbit, I'm going to do auto orbit. It's taboo, I know, for legitimate terraforming, but I had to cut corners somewhere. Glad it just wasn't somewhere else. Oh well, okay, thanks for bringing us nice and close. I'm getting proud of our creation so far, but there's still a few more things we need to do. Let's look at the composition of water. Is it still too hot for water? Okay, it looks like the temperature's decreasing. Interesting. So let's give it some time and see if it keeps decreasing further. We're gonna have to give it several years. Okay. It's taking literally centuries for it to decrease. Okay, it's stabilized at around 300 degrees Celsius. Notice that we're in the year 2500 now, so this isn't really feasible in terraformation time. Well, I guess so. Because it would actually take tens of thousands of years to fully terraform a planet with our current technology, or even a couple more years advanced. Let's decrease. Or maybe we need to increase water, because there's really no water on the planet. So first, let's cool it down. We're letting it rest at about half of that. Okay, never mind. It just climbs even further. So maybe we do need to add some water. So here's where we're going to use the scalars. We're going to go up to the different composition pieces of our planet. So there is water. Let's see what this is in ocean mass. Ooh, it's like 0.00005%. That's insane. So we need to turn it up a little bit. Let's multiply it by 10. Or I don't think we can do that when it's like this. Okay, 1% is a little insane. Yeah, there we go. So notice it has water now. But it's not going to last very long if we don't do a few things. First, we need to actually change average temperature. Minimum temperature, maximum 46 degrees Celsius. So, oh, there's a stabilized temperature. Oh, that's not good. Okay. Didn't want that. So if I stabilize temperature, it's going to go back to its normal level. All right. Settle water. I like these new features. Sea level 2 kilometers. That's pretty deep. It's about 1/5 of our current one. So how about we change this to 2 atmospheric masses? See what it does. Okay, so notice how you can kind of see the oceans now, and the clouds are very clear, but you still can't see discernible features of the planet itself. You can just see some of the atmospheric color. It's like a sickly yellow color. We don't want that. It's gonna change? Oh no, it looks like the temperature is stabilized. 7 degrees Celsius. So it looks like we've done a relatively good job in terraforming the planet, even though it's not very realistic. Now we want to do, okay, this is probably why atmosphere realistic. Is that a realistic atmosphere? Is there land on it? I don't think so. Let's try decreasing the water content. Okay, now there's like no water. Let's turn off atmosphere for a second, see what the surface looks like. We go to visuals, go up to atmosphere, turn it off. So this is what it looks like. What's with the white? What is that? Is that ice? Snow? Oh, it's snow. Okay, it looks like we do have some land masses. And the vegetation color is supposed to be green, but it's not on, so... Wow, I love that. It looks like there's a massive ocean separating the northern and southern hemispheres. I don't know if this could be due to impact scarring. You know, the craters of the planetoids I threw were going to be massive, but they're buried under an ocean now, so... Oh well, that is gorgeous, though. I love that. Let's turn back on the atmosphere. So, things would be looking pretty bleak for our planet. Just the horizon, the sunsets would look very sickly yellow. Let's see how Earth's doing in here. Oh yeah, that's fantastic. Alright, so before we end the video today, I'm going to attempt... Or know what? I'm going to end the video with some massive explosions. So we got our terraformed Venus. So now what I want to do is I'm going to blow up Earth. And this is going to look glorious for all of you viewers down below. Let's take a look at some of those city lights. Oh yeah, it's so gorgeous. I love that. I love all the detail they put into Earth, our home planet. Probably put more detail into that planet than any others. So let's see what happens instead of just blowing up the planet outright. Let's see what happens if we put... Okay, it's not on the same orbital plane. Let's put Kepler 62f in Earth on the same exact orbital plane. Okay. We're gonna have to throw it like this. So if they're really close to each other, will they attract each other over time? Especially since Kepler 62f is way bigger. It's very cold too, oh my gosh. It's a rogue object? Does it not have an orbit? Let's change it to auto orbit. Motion. Auto orbit. Okay. Distance from the sun, or simulation origin. Let's do orbital parent. Oh wow. Is it orbiting Earth? I don't believe it is. So let's see what happens over time. Oh shit, they collided. Okay, we missed that completely. I wish there was a way to reverse the simulation. So the two planets just collided big time. And now they're doing this weird dance of death together. They both technically exist, one inside the other. So now that we did that, and that wasn't even an intentional impact. Let's see how it affects Kepler 62f over time. Earth is at a very weird orbital plane. Well, it's not even Earth anymore. So I don't think that would have affected the orbit at all. And it's cooling off, so let's give it a couple of centuries. Okay, it's getting very close to Venus at some points in its orbit. And this is a very strange solar system we've created. I kind of love it. Kepler 62f, how are you looking? It has oceans, believe it or not. I think it took Earth's oceans. It has literally no atmosphere, though. Does it have an atmosphere because it's maintaining a temperature, or is it just because of its proximity to the sun? We go down to surface. Yeah, no atmosphere to speak of, but it still has liquid water for some reason. So this would be a very irradiated planet just because of solar rays. Alright, y'all, we're gonna go ahead and end the video right there. Sorry about the fact that I wasn't able to do more in this video. I just spent the whole video focusing on Venus, and I'm okay with that. So if you enjoyed this video and you want to see more like it in the future, maybe a part 2 on planet terraformation, let me know by hitting that like and subscribe button down below, because yet again, it really helps motivate me to create more content for you on the long run. Other than that, I hope you have a great night. Thank you so much for watching.